The elements of this matrix A are 1, 2, -1 and -4. -1 and -4. So we can now say that two matrices A, for example, are equal to each other only if matrix A and matrix B have the same number of rows and the same numbers of columns. And if each element of A is equal to the corresponding element of B, this is where we can now conclude that matrix A is equal to matrix B. For example, if the following two matrices are equal, for example, if the following two matrices are equal, that is, supposing we have these two matrices A, which is equals to 1 alpha -1 minus beta. We have another matrix B, which is equals to 1, 2, -1 and -4. Supposing we have these two matrices and we agree that the two matrices are equal, then we can conclude that alpha is equals to 2 because alpha is in first row and second column, and the position of similar value in matrix B, because they are equal, is 2, because 2 is equally on the first row and the second column. Then likewise we can say that minus beta is equals to -4, which implies that beta is equals to 4, with the same ideology that beta is on second row and the second column, whereas the corresponding element there too is -4 because it's on second row and second column. So we can conclude that alpha is equals to 2 and beta is equals to 4 because the two matrices are equal. They are equal. Then we move to another matrix that we call the unit matrix. The unit matrix. The unit matrix. You can see from the name unit. So the unit matrix or the identity matrix, another name for this unit matrix is identity matrix, which is denoted by I subscript n, or simply or often denoted as I. In some cases we denote it by I subscript n, or in many cases we denoted it by this. Is the diagonal matrix of order n. Diagonal matrix of order n. That is, the order of that diagonal is n. In which all diagonal elements are 1. All diagonal elements are 1. For example, supposing we have this type of matrix. We have this type of matrix. We have this type of matrix 1, 0, 0, 1. You can see the order of this diagonal. This is the diagonal, and you can see the order of the diagonal is just 2. So I can rewrite this as I2 because the diagonal is contain 2 elements. So in this case, I will say that the diagonal is 1, 1, and the element of this is 1 and 0. In this case, we can call this a unit matrix or a diagonal or identity matrix. Another one is this. Let's say we have this. Another example is where we have this type of matrix. You will see that the diagonal consists of 3 units. So I can write this as 1, 3, I 3. So in this case, this is also a unit matrix because the diagonal are 1 unit. They are units. So, or we could call it an identity matrix. In this case, they are all square matrix. Another type of matrix we also look at is the zero matrix. 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 The zero matrix or null matrix, can call it a zero matrix or we call it a null matrix. In the matrix, all of those elements are 0. The matrix is the matrix, all of whose elements are 0. All of whose elements are 0. Then there is a zero matrix for every size. There is a zero matrix for every side. For example, we may have a matrix of 2 by 3 and 2 by 2. So in that case, when we have 2 by 3, so that is we have 2 rows and 3 columns. So for example, we have this. Can see this one matrix A consists of 2 rows and 3 columns. In this case, when you have the element to be 0, then we call it a zero matrix. And in this case, you can call it 2 by 3 matrix. Suppose we have another one like this. This is also a zero matrix, but in this case we have 2 by 2 matrix. So in essence, a zero matrix or null matrix is the matrix all of whose elements are 0. So zero matrix of whatever size are denoted by this. Zero matrix of whatever size are denoted by this. You write 0 and we put a dash under it is denoted as that. So you should note that too. Another important term that we need to know is the transpose of a matrix. Transpose of a matrix. The transpose of a matrix. Transpose of a matrix. The transpose of a matrix A is a matrix where the role of A becomes the columns of the new matrix and the column of A becomes its row. That is, the transpose of a matrix A, for example, is a matrix where the role of matrix A becomes the columns of the matrix and the column of A becomes its row. The column of A becomes its rows. For example, supposing we have this matrix A, which contain or consists of this element. consists of this element. So if you want to find the transpose of this matrix, so transpose of this matrix, if you want to find the transpose of this matrix, this matrix can now become, I will change the row which consists of 1, 2, 3 elements to be the column 1, 2, 3, and change the second row to be the column. So you can see if I do it in this form, then it becomes a transpose. The resulting matrix is called the transpose matrix. So what you have is called a transpose matrix of A and denoted by, so we can denote it, we always denote this thing as A raised to power T. It's denoted as this. In the previous example, in our previous example, it is clear that a transpose of a matrix is not equal to A. You can see, and you also bear with me that if you look at the example of what we have now, this transpose is not the same thing as this, because this is another matrix, but the matrix A consists of 2 rows and 3 columns, but the matrix transpose of matrix A also consists of 2 rows, 3 rows and 3 columns. So you can see the first one is 2 rows, the second one, the transpose is 3 rows. So the A matrix A is 3 columns and the transpose is 2 columns. So they are not equal to each other. Since the matrices are of different size, if A is equal, is a square matrix. If A is a square matrix, that is, they are n by n matrix, then transpose will also be n by n. For example, that is, if they are square matrix, you can see this is not the square matrix. That is why the transpose are not equal. But if the matrix is a square matrix, they will have equal transpose. Let's say, for example, let's see an example of this square matrix. Suppose we have a matrix A with this element 1, 2, 3, 4, 5, 6, 7, 8, 9. Supposing I have this matrix, we are given this type of matrix, and we are asked to find the transpose of the matrix. Transpose of the matrix. So I've told you that to find the transpose, the row will become the column. So the first row will be on the first column, the second row will be on the second column, and the third row will form the third column. You can see. So in this case, you see that the transpose have the same row and the same column because it's a square matrix. Because it's a square matrix. Both are 3 by 3, but matrix A and transpose are clearly what? Different. Both are 3 by 3. They are not the same, but they are both 3 by 3. But matrix A is not equal to matrix B. They are clearly what? Different. So another term that we need to know, we have different series of examples. So you can now go to addition and subtraction of matrix. Addition and subtraction of matrix. Additions and subtractions of matrices. Addition and subtraction of matrices. Under what circumstance can we add two matrices? That is, supposing we have a matrix A and have a matrix B. Under what circumstances can we add these two matrices to become A matrix A plus B? Under what circumstances can we do that for a given matrix A and B? So consider matrix A. Consider, for example, let's consider a matrix A. Let's consider a matrix A to be equal 1, 2, 3, 4. And have a matrix B to be equal 5, 6, 9, 7, 8, 10. Supposing we have these two types of matrices, there is no sensible way to define A plus B in this matrix. There is no sensible way to define A plus B in this matrix. That is, to find A and B of this matrix, there is no sensible way to define that. In this case, since A and B are different sizes. If you look at it, the matrix A consists of 2 rows and 2 columns. While matrix B also consists of 2 rows but 3 columns. 2 rows but 3 columns. However, if we consider matrices of the same size, then addition can be defined in a very natural way. That is, if these two matrices have the same row and the same column, then we can do the addition A plus B naturally, like the way we normally add our normal figure. Let's take, for example, let's consider this matrix A. Let's consider the first matrix A, and we have another matrix B. We have another matrix B to be 5, 6, 7, 8. Supposing we have these two matrices, you can see the matrices have the same row, 2 rows, 2 columns, 2 rows, 2 columns. So we can then add these two matrices to form this addition. Therefore, A plus B will now be equals to, you take it the position they are in each of the matrices. This will be A plus 5, because 1 is the first row and first column, 5 is also equally the first row and first column. Then we have 2 with 6, we have 3 with 7, and we have 4 with 8. So which means our A plus B matrix will give us 6, 8, 10, and 12 to form another matrix. This is another matrix. So in general, if matrix A and matrix B are both M by N matrix with the element Aij and Bij respectively, then their sum is in matrix C. So instead of writing this, I can write it, I can call this the summation to be C. I can call it to be C. So I'm also saying this. The same way happen to subtraction of matrix. The same thing happen to subtraction of matrices. It follows the same pattern. So let's use a matrix that we have. So to have this, supposing we have matrix A and matrix B, the same matrix. Supposing we have matrix A to be 1, 2, 3, 4, and we have a matrix B to be 5, 6, 7, 8, then I can now find the difference between matrix A and B. So, and that will give us the same way. 1 minus 5, then 2 minus 6, then 3 minus 7, then 4 minus 8. Can see, because of the position is A differences B, not B differences A. So A must always come first. The element of matrix A must always come first before that element of matrix B. So I will now have this. This is minus 4. This is minus 4. This is minus 3. And this is minus 4. So I formulate another matrix which I can call matrix D to be equal to minus 4, minus 4, minus 3, and minus 4. No, it's the same minus 4, sorry. It's the same minus 4. So let's quickly look at the multiplication of a matrix by a number. How do we multiply matrix by a number? The addition and subtraction of matrix, I can use another matrix. But what I was trying to say is that before you can add or subtract any matrix, they must have the same format. That is the same row and as well as the same color. So let's quickly move to subtraction, multiplication of the matrix by a number. Multiplication of the matrix by a number. Multiplication of the matrix by a number. Of a matrix by a number. That there is also a natural way of defining the product of a matrix with a number. Using matrix A above, that is the matrix A we'll use as an example, which is this. A is equals to 1, 2, 3, 4. This is our matrix A. This is our matrix A. We noted that matrix A plus matrix A, that is 1, 2, 3, 4. Plus 1, 2 plus 2, 3 plus 3, and 4 plus 4. We noted that matrix A plus A will give us 2, 4, 6, and 8. We noted that matrix A plus A will give us that. This implies that I multiply matrix A by 2, that is A plus A is equals to 2A. So it means our 2A is equals to 2, 4. Is equals to 2 of our 1, 2, 3, 4. And if you do this, you see that 2 times 1, I will have 2, then I will have 4, I will have 6, and I will have 8. So it means I multiply. If I add the two matrices of the same type together, it means like a way of multiplying it by 2. So in general, if A is an M by N matrix with typical element Aij, then the product of a number K with the product of the number K with matrix A can be of this way. That is, our A now is this, and our K is what? Is 2. So let's take another example. That if I ask you to multiply my A by 7, so it means I have 7 outside this, and that will give me 7, 14, 21, and 28. So you can see, in this case, I'm multiplying a constant or a number by, I'm multiplying a matrix by a constant A. I can have another one if my constant is minus 3. Let's say my constant is minus 3. It's still the same way, that is 3A will give me minus 3 outside, then 1, 2, 3, 4. This equally also, I will have minus 3, minus 6, minus 9, then minus 12. So it's still the same way. So I'm multiplying a matrix by a constant number. Let's quickly look at some simple matrix properties. That is some simple matrix properties. Some simple matrix property. Basic property of matrix. Using the definition of matrix addition described before, we can classify easily, verify the following. We can verify this following easily.